right, I guess we can start. So hello, everyone. Welcome to today's Ask Tom webinar. The topic is JSON, but it's not about generic or basic JSON stuff. We are going to cover together with my colleague Herman Berg. We're going to cover the new features of JSON, both for DBAs and developers. And as you can see in the title, we have duality in brackets. The reason is the emphasis is on JSON duality. However, we will cover also some new features of JSON. And when we say new features, we mean Oracle 23.6 and Oracle 23.7, the latest RUs. All right, let's start. So in the last year, meaning calendar year 24, the popular website dbengines.com, which on monthly basis follows the popularity of the databases the same way like ATP is following the tennis players in the world, is showing how the database brands, and at the moment there are more than 400 database brands. I checked this morning, 424, which can be downloaded and configured. The most popular ones that you see on the screen are from Oracle to SQL Server, containing also MongoDB. You can see that the popularity of Oracle has grown significantly in the last 1 year, most from all significant databases. By significant database, I mean the most common database brands. And on the opposite side, MongoDB's popularity is fading away. As you can see, they're down the list. Only SQL Server is doing worse than they are. And in fact, it's no surprise because as noted by CNBC, every single Fortune 500 company at the moment is using Oracle database. Every single Fortune 500 company. The question which we pose to ChatGPT is, since our presentation is about JSON relational duality, is it important for both DBAs and developers? And as you can see, the answer is that it is significantly important both for DBA and developers, because it actually bridges the relation between JSON models, between semi-structured data and relational data. And on one slide, we have the answer here for why it is important for DBAs. Why should DBAs know about JSON relational duality and JSON in general, which at some point I've been questioned by DBAs if they should really care and know anything about JSON. Yes, indeed, is the answer. And there are 4 important points. One of them is simplified data management. DBA managing an Oracle database needs to understand what the database, how the database stores JSON and how JSON can be tuned, and all the details about JSON duality as well. Performance tuning, you need, of course, to be able to create the right indexes and optimize your JSON storage. And of course, security, you worry about relational data security the same way you worry about JSON security. And then, of course, there is the reduced storage redundancy. For developers, of course, it's more clear probably for most of us. It's the flexibility in development, because data can be represented both in the relational and JSON format. There is a very simple data model, which developers don't anymore need to manually map JSON data to relational tables or the opposite way. And of course, the power of using SQL. We know that several customers have moved out of MongoDB to Oracle for the reason that they're not able to run analytics and reportings on their Mongo databases. And of course, the collaboration, the streamlined collaboration, developers can focus on JSON-centric application, while DBAs can manage the relational backends. So that's what came from ChatGPT. Herman, I see that, oh no, it's a question from you. All right. All right, so here's the agenda for today. We'll cover first the new stuff that came in 23.6 and 23.7. Then we'll cover the Mongo to Duality migrator with a live demo, and we'll go a little bit deeper into the details, discussing what is flex columns, what is an outlier, and what is minimum frequency. This is both important for DBAs and developers, especially for DBAs. And it is important to note here that in the Mongo to Duality migrator, 23.7 has some, I wouldn't say major changes compared to 23.6, but you see that some things have changed. So you need to understand also very well how 23.7 differs from 23.6 in terms of migrating. Then we'll cover what is JSON collections and also the MongoDB API, followed by a live demo and a wrap-up. So let's start with the first topic for today, the new features in 23.6 and 23.7 for JSON. It is probably a slide that you have seen. The Converge database covers not only covers every single data type. At the moment, I think in the Oracle database, there are 26 or 27 different data types, the last two ones being JSON and vector. And if we look retrospectively in JSON in the Oracle database, the JSON data type in the Oracle database before this calendar year 25, we see a history of almost more than 10 years, actually. First, JSON was introduced into the Oracle database with 12c release 1. And in red, you can see arguably the most prominent important features that came around JSON. In 19c, we introduced the MongoDB API. In 21c, actually, it was in 20c, but 20c was actually rebranded as 21c. We introduced the native JSON data type, and then 23c, with the name 23c, introduced duality views, which is the main topic of this webinar. And with 23 AI, we introduced the migrator, the tool that migrates automatically from MongoDB or any other document store to Oracle, which we'll show today how it works with an example, with a live example. Hopefully it works without any hiccups. And JSON collection tables, which will be also covered in detail today. Let's start. So new in 23.7. So I'll try to specify which feature is introduced in 6 or in 7. In 23.7, when you create write the DDL for duality views, now you can do the following. You can do two things. If in order to identify the columns that selects the rows for updates, you can use the field name _ID in sub-objects, and that's possible even there is no unique or primary key constraint. This is a significant release, significant improvement. And you can also use an identity column as the identifying column in the duality views. Those DDL new enhancements, they let us have more use cases supported by JSON duality views. Now, the second one is about indexes. So a topic both for DBAs and developers. You can now create JSON search indexes with path subsettings. And when you create such an index, you can specify the fields which you would like to include or exclude from the index. And you can reduce this way the size of the index, and not only reduce the size and the storage of the index, but also improve the performance. So let me show you here with an example how to create such an index. This came in 23.6. Before that, I would like to show you the collections that I'll be using for today's demo. And I'll show it through Mongo Compass. It is a collection called Coffee. Let me show it a little bit in a little bit different way first, more looking like an Oracle relational table, although this is a JSON collection. So we have 12 documents in this collection. We have different types of coffee. That's why it's called coffee. We have espresso, cappuccino, and so on. We have the price. Notice that some prices are numbers and some are characters. And we have the size of the coffee. It's either short or tall or grande. We have the quantity. We have also for this coffee type. Now note that some of the rows in the table, some of the documents in the collection, they contain some fields which do not exist in every document. For example, for espresso, we have an additional field, coffee items, which is an array, and it contains the description of the different types of espresso. So we have Italian espresso, we have Finnish espresso, and we have different code for those espresso. So this is not present in every single document. So the general documents, they just have the item, the price, and the size. All right. So now let us create a search index, a path subsetting index on this collection, and I will be using Oracle Autonomous Database, Autonomous JSON Database. We are going to forget today about SQL Plus and SQL Developer. We'll use SQL Developer Web. Now let's open the interface, SQL Developer Web. And if we want to create on the coffee collection, if we want to create a search index and include, for example, the size and the quantity and also the price, we can use the following syntax. This is new in 23.6. Let us see what will happen. Here it says index created. Also, I can do something different. I can also try to create here an index. Probably you can see I'm copy pasting the syntax because I don't want to type it. We can create a partial index. A partial index is created the following way. Let me copy first the command into SQL Developer Web. I won't drop the previous index. We are creating a partial index, and we're using the syntax case. In case the price is less than 5 or equal to 5, then we index the price. Otherwise, we do nothing. So actually, we're indexing all the fields which have price at most 5. Let's see how it works. Here it is, index created. So this is how we create indexes in 23.5 and 23.6. Going back to the presentation, it's worth mentioning also that hybrid vector indexes now can be built on JSON columns. Vector is the latest improvement of the Oracle database. And if you use hybrid vector indexes, you can very easily index and also run SQL on your documents using a combination of both full text search index and the semantic vector search. You can, of course, get this way better, higher quality search results. New in 23.6 and 23.7 is the limit clause in the JSON data type. So now we have a limit clause which can now limit the size of the JSON data, which you insert into the database. So you can see the simple example here is create table test. The column C1 is JSON data type, but we limit it to 7,900 bytes. Now, this is new to 23.7. However, I think it works also in 23.6 because I tested today in 23.6 also works in 23.6. Why you might want to do such a thing? It's because of optimized efficiency. So if you want, for example, to limit the application to be able to insert only small size documents, say less than 8,000 bytes, in 23 AI, we improve the performance without, there are no code changes. If the JSON is small, those will be inlined. So anything below 8,000 bytes is inlined. We had the restriction of 4,000 bytes in 19C. Also in 23.7, we have now a new syntax for the logical replication clause. So when you create table or alter table, you can specify that partial JSON updates would be available under supplemental logging. So you make the replication more efficient because then you don't need to replicate the whole JSON, you replicate only partial JSON. And this is done by using the syntax enable logical replication, partial JSON. This is not the default. In 23.6, we also introduce hidden and generated fields in JSON-Relational Duality Views. And as you can see, you can create a table, a relational duality view based on a table called emp by having a column which is hidden, the wage column and the tips column. And you can also use a generated column. For example, here the total compensation is generated from the sum of wage and tips. And you can also have even a Boolean field, the last one, high tips. When the tips are bigger than the wage, this generates a Boolean type field. So bottom line that you can have hidden and generated fields. I won't spend much time on Golden Gate replication for JSON duality views, but now this works. This is very useful, especially if you'd like to migrate out of MongoDB and you want to have a live migration. Also, you don't need to replicate all the JSON data that you need to replicate. You can just do the replication of the JSON duality views. And this works as of 23.6, so it works in 6 and in 7. Now, let's move to the Mongo2 Duality Migrator, the new tool, the PL/SQL-based tool. and figure out what is the meaning of those new concepts: flex columns, outliers, and minimum frequency. Now, with flex columns, a duality view, flex column will store the JSON objects that are not predefined. So the values that they cannot be mapped to a specific underlined column. You can then add fields to document object produced by a duality view with a flex column which underlies the object. You don't have to redefine the duality view. And if a given table which is below the duality view has no column identified as the view as flex, then tough luck, then you won't get, you'll get an error message probably. Those flex fields, columns where you want this particular kind of flexibility are not automatically added to the object produced by the table. And it is important also to note that when we speak about flex fields, we speak about flex columns of duality views. They're flex for the views, not for the table. Maybe it's better if I explain that with an example, because with words, it's more complex. Let me go back to SQL Developer Web, and I will create a table called person. And on top of that table, I will create a JSON duality view. Now, let's first create the table. We create a table person with number, which is the primary key, and we have first name and last name. And then we have the extras, which is a JSON object. Let's create the table. Pretty simple. Table person created. Now let's create a duality view, and we call the duality view person merge duality view, and we use the primary key, the ID, underscore ID, the first name, the last name, and the extras, which we define as flex. This is the syntax. Let us create the duality view. And now once we have the duality view, let us insert some data. Let's insert 3 rows, 3 documents, actually. Here it is, state JSON duality created. And let me show you what I'm inserting, actually. That's important. So I'm inserting first first name beta. And notice I'm inserting a nickname, which was not part of the table. There was no column called nickname, and in the duality view, I don't have a field called nickname. And for beta, we have Dr. Jason. For Herman, we have no nickname. And for Julian, we have Ju. Let's insert the 3 documents. Right, let's see what happened. And then let's commit. Double M. All right. Now we can check what data we have first in the duality view. Let's see what data we have for ID 33, which is Julian. Let's run the select. And here is the data. You can see as you can see, you cannot see anything because I cannot open it. Here now I managed to open it. You can see that we have the nickname Ju. It comes from the select based on the duality view. Now, if I would like to update the duality view, I can update the duality view and add another field. I can add a new field for the duality view called country. And for me, it would be Finland. Let's try to update it. And one row updated, let me commit. And let us again check what happened with the data through the duality view. as you can see, let me just open it. Also, the new field was added. So those are the flex fields. Those are the fields that basically do not fit anywhere. And in the duality view definition, actually, you cannot insert the same JSON column as flex column in a document and a non-flex column in another place. You get an error message. What is particular about the JSON column that's designated as a flex column for a duality view is that, as you remember, the column name must be JSON object. That's how we created the table. And this means that it must be declared as JSON object. Let me show you once more how we created it. I'll go to the syntax. You can see here, extras was JSON object. Now, what is minimum frequency and an outlier? This is important for the JSON to duality migrator. So if a field occurs in a certain document, in a number of documents, in a less percentage than the minimum frequency percent of the document, then that field is considered an outlier. Meaning, if we have, for example, 12 documents, and let me show it to you again with an example because it's easier to understand. You can see here that we have 12 documents, and the coffee items field is an outlier because it exists only in 2 documents. It exists only in the Finlandia coffee items, and it exists only in the first document called espresso, with the espresso item. By default, the minimum frequency is 5. So if more than 5% are, if less than 5% are available, or you in the documents that you have in the collection, then we consider those fields as outliers. And we have another one, which is called brand. You can see the field brand. It exists only in one document. We have a brand called relax that doesn't exist anywhere. That also is an outlier because it's an exceptional field. It exists only in a very small amount of documents. Now, the interesting story here is that up to 23.6, we had only minimum frequency. But starting 23.7, we split minimum frequency into 2 parameters, field frequency and type frequency. Field meaning the name of the field, and type frequency is the type of the field, which I showed you here in the example that in the collection coffee, where we had some prices which are as characters. The rest are numbers. So if we have minimum frequency as 0, so nothing will be considered an outlier. But if the minimum frequency is 20%, those 2 will be considered as outliers. Now, going back to what new is in 23.7 is the 2 different procedures. One of them is called import all, which is used for importing with the migrator all the collections altogether. If you want to import only one collection, it's import. And we also have a new procedure called validate schema report, which will give you a report on the relational data and probably to help you validate if the data is correct, if there is no data lost. And when you migrate the documents to duality views, it will show you the information that you probably need in order to validate if the migration is fine. So finishing now my part, I will show you how this works. I will run the migrator onto the collection called coffee. This is for 23.7, and this is the whole PL/SQL block that you need to run in order to migrate it to a relational model, and top of that, having the JSON duality views. There is the new package called DBAs JSON duality, and the new procedure infer and generate schema. Here, I'm migrating the coffee collection. I'm using flex fields. I'm making the duality views updatable. I'm having the minimum field frequency to 20% and the minimum type frequency to 20%, and I'm having the admin schema as the source. Once the SQL is being generated, this is the CLOP, which will be actually a long string, which creates the structure of the relational data, like the tables, the indexes, and then even the sequences. At the end, we will import the data into the duality view. Actually, we're not importing in the duality view, we're importing into the underlying table of the duality view. So if everything goes fine, this will work and we'll be able to migrate the coffee collection into relational structure with duality views on top of it. So let us run this block. That is a small collection, so it should happen quickly. And we can see that PL/SQL was successfully completed. So that's all. That's how you migrate from collections, say from MongoDB or any similar database. And you have at the end, you have the whole relational structure, you have the duality views on top, and you also have the data imported. And if we want to see what actually happened, this is the last thing I want to show you before we continue with collections. I might run a select statement on DBA object. So select star from DBA objects, where, and I won't select star, I'll select owner, object name, and object type from DBA objects were created, something what got created very recently. So sysdate -1 divided, say, with 240 and order by object type descending. Hopefully I typed it properly. And here is what the duality migrated tool created for us. Here are the objects that were created. I'm waiting for the output of the statement. Now this is interesting. Then I'll probably directly will go to MongoDB Compass, I'll update, and I'll show you that I have the coffee duality here, the coffee duality view. You can see this is the coffee duality view. And actually, it is exactly the same it is used to be. Have a look. This is exactly the same like the collection we had in the beginning, but this is the duality view on top of the tables. Let me see if everything works fine. So I don't know why this is not returning anything and is just hanging. This is the fun of live demos. But we have, no, I have here a typo actually created. This is a typo. Well, one other thing I can do is I can move to SQL Developer and run the same statement. Here it is, much faster. So, so we can see that Oracle created for us a table called coffee root. Oracle created a sequence and a couple of indexes and the duality view. And if we want to see what the table looks like, this will be the last command I'm going to run. We can select star from coffee root. This is the relational table that Oracle created based on the collection data. So here it is, as you can see, and you have the flex column here. So this is the data which was considered an outlier. All right, I think this is all from my side for now. I will hand over to Herman, who will continue. Herman, is it with collections?
Yes, give me 1 sec. Let me share my screen. I got slightly distracted with the QA. Had to try out something. Okay, collections. Let's switch the gears. Thanks for your part, Julian. The theme was, okay, what's new in duality views and JSON in general with 23.6 and 23.7. And there's something that happened on the overall collection side. I will walk through a number of collection features with you together, and I'm going to show you this also live. But to actually level set of what we are talking about when we're talking about collections. So a collection, So Julian talked about the duality views. He showed you how you can use the migrator and actually work with these things. But now looking into what is a collection? A collection is basically a special type of table or view in the Oracle database that only stores or retrieves JSON. And the duality view, just a spoiler right away, a duality view is a type of a JSON collection. And what makes a JSON collection special is that its purpose is to retrieve documents and only documents, meaning that a JSON collection has a fixed shape of a single column named data that returns JSON data type. It also has the requirement that you have an underscore ID field that is either generated by the database or that is inserted by you. That is a unique immutable indexed primary key that identifies a single document in your collection. And when you don't insert it, the database will do it for you. So with that framework, basically enforcing a fixed single column shape on the table that returns JSON, plus requiring that every document has an ID column. This makes JSON collections in any way, shape, or form automatically compatible to Oracle's simple Oracle Document API and to the MongoDB API. It is still a first-class database object, as you see on the little example on the right-hand side, that you can work with SQL with, but it is automatically compatible with the document store API, SODA and MongoDB API. So what kind of JSON collections do we have in the database, right? I made the spoiler. A duality view is a JSON collection. It's a type of a JSON collection where we store the metadata for the defined JSON collection in the database alongside the initial storage of the data in its relational form. So the description of it is defined by SQL or by GraphQL, as you see in a little example slide. What we added officially in 23.6, so it partially worked in earlier releases, but we officially documented and exposed it in 23.6, is something that is between a collection table, which is basically the first class table object where the data is stored in a binary JSON format, and duality views that are fully updatable. We introduced collection views, and collection views, just like duality views, are defined by SQL. Those are 99.x% read-only objects. There's one corner case, but this is not really something that is exposed, because the idea is, collection view is meant to enable you in a very simple and pragmatic way to expose some relational data that should be visible within your document store API or the application that uses the document store API. So when we look at these two flavors, JSON relational duality views and these, what I call non-duality JSON collection views here, is they're both generated by SQL. So you define the construct where duality views have some more requirements to actually uniquely map it to the underlying framework to be fully updatable and have full DML capabilities. They're always generated by SQL, and they're both automatically visible in the MongoDB API and SODA collections, just like a JSON collection table. Now, the thing is, one question that we sometimes get, so now we have this JSON collection view. We also have normal views where we can expose JSON documents, right? So when you look at a JSON collection view versus a normal view with SQL, they, from a SQL perspective, they both look and smell the same, with the minor exception that with one we say we are defining a JSON collection view, and with the other one we are just saying a view. So from a return perspective in SQL, you will get exactly the same data, right? You have in both of these cases, the way of how I created it, you get the same data returned, but the normal view is not a JSON collection view, meaning that it does not have the collection metadata that comes along with that object. So a normal view, what you see on the right-hand side, is not visible in the MongoDB API or Soda. There's also one minor gotcha or minor thing that I want to point out. If you create a normal view, you have to create an alias for the expression. Whereas, you know, when you create a JSON collection view, you see we are just specifying the return type as a JSON object that consists of all the columns and values in the collection. We automatically name it data, right? So you don't have a choice on a JSON collection view. Again, collections, JSON collection are first-class citizens in the database, but they have a predefined enforced shape. So now some people of you might work with Mongo or Soda as well as with Oracle. And one of the things that you are probably familiar with, and sometimes, you know, you just learn it by running into an error, is that the naming between the Oracle ecosystem dating back a couple of years and the MongoDB, sorry, or the Soda naming is slightly different. So in the Oracle world, when you create an object, table, index, view, whatever, and you don't double quote the name, Oracle always capitalizes the name that you create in an object. Now, when you look in the Mongo side, if you create a collection and you just name the collection, the name is case sensitive and is preserved as you type it. So if you type a create collection view in all uppercases or collection view in all lower cases or in mixed cases, right? The name as you type it in is preserved, and that's the name of the collection and the object that you deal with in the world. Whereas if you create a table foo in lower cases, upper cases, mixed cases without double quoting in Oracle, you will always get the uppercase name. So now we thought about what can we do to actually bridge this gap in behavior without basically breaking what Oracle does for the last 30 plus years here in the namespace, to make the core behavior of these systems transparently the same. So what we do for these objects, and that is actually true for collection views, for collection tables, as well as for duality views, is that we automatically create a synonym if there is a mismatch between the name that you define in the SQL world, right? If I'm talking about the SQL world, when you come from the Mongo world, we always, you know, decorate names with double quotes and you get it preserved as you put it in. When you create an object, we automatically create basically the counterpart for the other world, right? So if I create a table foo in lowercase in Oracle, it is stored as a table foo in uppercase. We automatically create the synonym foo in lowercase to preserve the name that was given at that point in time to the JSON collection. And the same is true if you do double quotes, which is the statement as it would come from, for example, if you do a create collection, as you see on the right-hand side, we automatically create a synonym foo in uppercases in the Oracle world, so that the people that are coming from an Oracle world get their capitalized names as they're used to have it, and the people that come from the case-sensitive world can work with their name as they're used to using it. So this is how we are providing naming transparency for the MongoDB API. Another feature that we actually introduced in 23.7 now is hidden in this simple example. So I'm jumping back and forth between collection views and collection tables because we wanted to cover new features that were coming up in the latest releases. And one of them is actually hidden in this statement. Some of you might see what the difference is in that statement as compared to the old versions. It is the keyword materialize, right? So you might be familiar with the fact that when you create a JSON collection table, it has this fixed logical shape of a single column data of data type JSON, but it's still a first class table where you can work with it just like with a normal table. You can move it, you can rename it, you can add and drop virtual columns or expression columns to extract specific attributes as a relational entity to it, which you then, for example, use to partition such a table. And with that, we give you now the capability in 23.7 to explicitly express that such an expression column can be materialized on disk. So Oracle introduced what we call virtual columns many, many moons ago, and they were always derived at data access time, meaning that if you select the value of an expression column, virtual column, it is generated as you access the data. Now, what we have seen specifically when you come to things like, creating partitioning or this kind of stuff is if you access such a column very often, and if it's potentially becoming an expensive operation to retrieve that value, it is beneficial to materialize this value at record creation time. And this is what we added in 23.7. So now this is a feature that is not only there for JSON collections, but for any kind of expression column or virtual column in the Oracle database, for any kind of table. It's just very handy in the context of JSON collection tables. Julian talked about JSON search indexes. I just want to point out this is a generic 23 AI feature, is that obviously when we're dealing with collections in a database, we can index these collections independent on whether those are plain JSON values within your document or whether these are arrays, values in arrays that you wanted to index. So this is just all there, and basically all that you're doing is we have special keywords, multi-value index, and then you just index the values within the array of an attribute in your JSON document. So this is just straightforward. There was a functionality that was not available in 19C, which actually closed that gap as compared to 19C. In 19C, you had to basically you had to denormalize the values into a materialized view, and we implemented materialized view rewrite in 19C environments to achieve exactly the same. Now we talked about JSON collections, and I said we are enforcing this shape on these type of objects in the database, whether this is JSON collection tables, JSON collection views, or JSON relational duality views, right? And with that, we automatically get this compatibility with the MongoDB API. And there's quite some things that have happened in the MongoDB API recently, which we put in the bigger umbrella of 23 as well, because the MongoDB API, while running as part of the Oracle REST data services, relies on functionality in the database. So for example, you can think of it like we cannot create transparently a multi-value index through the Mongo API if there's no multi-value index capabilities in the database. And one of the big things what we added just recently is not only the capability to support aggregation pipeline operations through the MongoDB API with the Oracle Database 23 AI, we actually went a step further and it sounds a little paradox, but it is reality, and I'm going to show it to you in a second, is we have Oracle proprietary Mongo compatible aggregation stages that you can invoke from a Mongo application or through a Mongo SDK, namely $SQL and $external at that point in time. So what do these two operators do. So $SQL is kind of self-explaining, right? It allows you to actually embed a native SQL statement or PL SQL operation within the stage of a MongoDB API aggregation pipeline. So this is the syntax. In reality, it would look like that, right? So this is a very simple example to actually just take the result of a SQL statement, rows and columns, and create the equivalent documents of the return set as part of this aggregation pipeline steps. So you could actually use that, for example, to create a collection in your database, right? If you add a $out stage, you are readily having the same data duplicated and copied into a JSON collection. But very often what we're seeing people using that, it is really in the theme of the converged database to allow you to combine core data, core values, core business KPI calculations transparently into a Mongo framework. So sharing the same logic between the relational world and the Mongo world. The second feature that we just recently added, I think it's about 2 or 3 months here, is a stage which is called $external, which allows you to specify and point to an external location that stores JSON documents and to retrieve them within your Mongo framework without actually having to do anything. You just point to that data and you're getting the data returned. So this is a simple example, just pointing to a JSON dump file in GitHub. And with that simple aggregation stage, you're getting the information of this external JSON documents returned into your Mongo application. Okay. Having spoken enough, let's just quickly walk through that stuff and show you some of the things live quickly that we get an idea. So let's just quickly check. Am I still connected? Yes, I am connected. Julian, is the font size big enough for you? And for others, raise your hand if
I
it's
think the
not
size is fine. It could be a bit bigger.
Okay, so let's make it bigger with the sacrifice of floor space.
That's fine now. It's readable.
Okay, cool. So I might have to scroll a little bit more. So the first thing what I'm just going to do is I'm just creating a just straightforward relational table, which you see, right? It just has 2 columns, a column 1 and a column 2. Very creative, right? So this is a relational table. And what we want to do is we just want to create a JSON collection view on top of this data. And let's quickly, before we go there, let's quickly go to, probably make that bigger as well. Log into this database with the Mongo shell as well. And check what we have in terms of collection. We have a movies collection. Okay, so now I'm creating this JSON collection view JV1, right? It is, as we said, right, it is a fixed enforced shape. You see, I don't give an alias, right, of a single column data. And that's about it, right? If you do a select star from JV1, you will just get the same, the documents are returned, right? If I do it, let's just do db.jv1.find. You will get exactly the same data back, right? And you see, this is one of the things, right? I use the lowercase name, despite knowing that Oracle actually created this view as an uppercase name, because I have not specified it, right? If I'm trying to insert something in that, and now I'm just using the uppercase name because Oracle is there, you will get an error, right? We will fix the error message. It's not the most creative and best explanative error message at that point in time, so we're working on that. But this is a read-only object, right? You will also have seen that I did not specify an underscore ID column. So with a JSON collection view, this is not necessary because it's a read-only object, right? If you are creating it just like I did it here, taking with the JSON syntax just the column names as they exist, well, you get the column names as the key of the columns, right? If I create it now, mapping it, you will see if I do JV2, you saw I mapped the column 1 and column 2 to actually more descriptive names like an underscore ID and an attribute. You will see these values being taken within your Mongo environment to work with that. But if you're trying to insert something here, it is still a read-only view. So now you've seen it is both of these tables are returning a JSON data type. So I want to point out a gotcha that is actually going to be addressed very soon. At the moment, we allow you to create a JSON collection view using the JSON object type operator. But due to backwards compatibility, this operator returns a varchar field. Very soon, that will throw you an error when you try to create such a JSON collection view. That is an outstanding issue from our side. We will correct it, and we will not allow you to create such an object, because if you try to use this, what did I call it? At the moment, we raise that at runtime, and this is not what we want to do. So you will get that error being routed to the kernel to create that right away. Now, we talked about what's the difference between a normal view and a JSON collection view. You saw I created a JV2, which had exactly the same shape. I'm now creating a JV3, which is just a regular view, which will return exactly the same to you as the JV2 does, right? But if you check the collections, there is no JV3 for you available. It's just the 1, 2, and 2b that we created before. Okay, let me just see. Obviously, right, if you have well, let's just skip over that in times. Okay, let's quickly talk about the synonyms that you quickly see that. We walked through that, but it's probably better just to see that live. And again, right, I have very creative names here. So I create a JSON collection table named foo, and you see I specified with lowercase. But oracles and the standard behavior for any object in Oracle is if you come with an unquoted name, is we capitalize it. We thought hard about whether we should change that behavior for JSON collection tables, but we decided to stick with the generic kernel behavior and to address this actually through the synonym path. So what you see for the table view, the JSON collection table that I created the synonym foo, meaning that if I were to do this, foo find, obviously I have nothing in there, but that works exactly like the upper name, right? Okay. So now if you create a JSON collection with the name, fully uppercase name foo, there is actually no mismatch between the name that you intended to give the collection and the way of how Oracle stores the name. So this is why, there is no need to create a synonym at that point in time. And last but not least, if you do a double quote name, which is, what you would get if you created from the Mongo side, is the table will be created with the name as is, because you enforced case sensitivity on the name, but we still will create the uppercase name foo. Okay, let me just check the time. I think partition key, I don't really have to show you a lot, right? Let me just see, is the table here? It's just, you see, I'm using the new keyword materialized. We actually support the keyword stored as well. Although materialized, this is for specifically alignment with other databases that currently support the materialization of expression columns. Let's probably quickly just before I get back and hand it back to Julian, show you a multi-value index. So you see I'm inserting into that table two documents, both with an attribute credit store that stores an array of values, right? And all you're doing here right now is when you create the multi-value index, you're creating the index on the array, and with the keyword multi-value, you're describing that this is actually an array that is being indexed, right? And now what I'm doing here, I'm just doing a JSON exists clause in SQL. I just wanted to say English, yes, in baby English, also called SQL. And you will see it uses an index range scan on the JSON tab. Okay, so time-wise, okay, one last thing that I probably quickly want to show to you folks is, since I bragged about that, is the capabilities to actually work with SQL and with external data transparently from within Mongo. So let me just quickly go here. So this is a simple example where we are pointing to a GitHub file. It's actually the same that you had on the slide as part of the aggregation framework. And what it does here is, under the covers, we are using inline external tables in the Oracle system and return that data. And obviously, you know, this is also a nice way you could do whatever. We are in the aggregation pipeline framework, right? So there is, let's just see, oops. So I can use any other operator here, like a $out, oops. I think I have to quote it. Oops. Single. You could add another stage and actually create a new collection. Documents. Okay, so we just loaded 10,000 objects. And the same way, you cannot only embed, transparently work with external tables, you can also transparently, as I showed you, execute SQL statements. So this movies is actually a collection in that database. And let me just quickly, oops. That's not what I wanted. Fat fingers. And you could do exactly the same with the aggregation pipeline framework, getting the same result. Okay, so sorry, Julian, I was talking too much, but let me stop sharing and hand it back to you for the wrap up. I just have to find my stop sharing button. Okay. Yeah.
Thank you very much. Thank you very much, Herman. Let me have one final slide before we complete. I wanted to share with you additional resources. So you can use our live labs. You can check our documentation where everything is, of course, described in more detail. And of course, you can always use our email or Twitter accounts. At the very bottom here, you can see Beta's Twitter account, Herman's Twitter account. It's the one finishing with 2000, and mine Twitter account. So feel free to contact us if you have any questions whatsoever. And I would like to thank you, everyone.